Part 2 of Section 5 is rational exponents. Rational exponents are exponents that are fractions. So let's start off with a to the 1 over n. Okay, so that is going to be equal to the nth root of a. All right, so let's look at an example. Let's say that our base is 16, and we want an exponent of 1/4. Okay, so we're looking for the fourth root of 16. Okay, well, that is a 2 because 2 to the fourth, or 2 times 2 times 2 times 2, is equal to 16. All right, another example. Let's take 27 to the 1/3. Well, that's equal to 3 because 3 to the third power, or 3 cubed, or 3 times 3 times 3 equals 27. Okay, so that's a exponent that is just 1 over some number n, some integer n. Now let's look at the case where we've got a is our base, and the rational exponent is some integer m over some integer n. Well, we can rewrite that as a to the 1 over n, and then that whole thing with an exponent of m. Okay, so if we kind of go backwards, we can see that we've got an exponent to an exponent, so we would multiply those. So multiplying that 1 over n times n, that gets us back to that rational exponent of m over n. Okay, so let's look at some examples. So let's take 4, let's back up. Let's take 4 to the 3/2. Okay, so we can think of that as 4 to the 1/2, and then that whole thing cubed. So 4 to the 1/2, we want the square root of 4, so that's 2, and then that's cubed, so we get 8. Let's look at another example. This time let's take a fraction. Let's step this up a little bit. Let's go 27 over 64, and rational exponent of 2/3. Okay, so we can break that up. We can take the 27 and put the exponent of 1/3 on that. All right, bring that inside the parentheses, and then the same thing with the 64. And then the whole thing would have the exponent of 2. So focusing on what's inside the parentheses, the cube root of 27 is 3, because 3 cubed is 27, and the cube root of 64 is 4, because 4 cubed is 64. So we've simplified the inside of the parentheses. Now we want to square that. So squaring 3/4, we get 9 over 16. Okay, another example. Oops. Another example, let's take 36 over 25 to the negative 3/2. Okay, so we have a rational exponent, and that exponent is negative. So we know when we have that negative exponent, we're going to flip or take the reciprocal of whatever the base is. So let's do that part first. So let's take the reciprocal of that fraction inside of the parentheses, and we'll rewrite that as 25 over 36. So that means now we've got a positive exponent of 3/2. So we first apply the exponent of 1/2. So that's taking the square root of the numerator, so that gives us 5, and the square root of the denominator, that gives us 6. And then that has a power of 3, or an exponent of 3. So now we cube the 5, we get 125, and we cube the 6. All right, that exponent applies to the numerator and the denominator, so we get denominator of 216. Okay, now we're going to put some variables in the mix. Let's take this example, 16x y to the 5th. That whole quantity with an exponent of 1/2. So we learned from before that 1/2 as an exponent is going to apply to each of those factors inside. So we'll have 16 to the 1/2, x to the 1/2, and y, we're going to multiply the 5 and the 1/2, so that exponent on the y is going to be 5/2. We can do a little simplifying here because we can take the square root of 16, and we get 4. So 4 x to the 1/2 and y to the 5/2. All right, let's look at another one. Let's take x to the 7/3 times x to the negative 2/3. All right, we want to simplify that, which means we want to write x the base one time, and we want positive exponents. So we have the same base x, and we have different exponents, so we can write that base x one time, and we can add the exponents. So we're going to add 7/3 plus a minus 2/3. All right, so we end up with x to the 5/3. So x, the base is showing up once, and we have positive exponents. All right, another example. Let's take 2a minus 1, that whole quantity, to the 1/2 times 2a minus 1 to the 3/4. So our base here is this thing in parentheses, the 2a minus 1, and they're the same. So that means we can rewrite this with that base just one time. And again, because we're multiplying, we add the exponent. So 1/2 plus 3/4. So we need to get a common denominator here. Well, we can rewrite that 1/2 with denominator of 4, so that's 2/4. So we end up with our base, 2a minus 1. Adding those together, we get exponent of 5/4. All right, another example. We got x cubed y to the 1/2 times x to the 1/4 times y to the negative 1/4. We want to simplify. Okay, so we've got just multiplication here. So we can think about multiplying these x cubed times x to the 1/4. So that's the same base x. That means we're going to add those exponents. Okay, and then we've got that same base y. So again, we'll write that base once, and we add the exponents. Okay, all right, so we got to get common denominator. So we got x, that 3 we can write with a denominator of 4 if we take 12 over 4, and then plus 1/4. And then the y's, we can rewrite that 1/2 as 2/4, and we got minus 1/4. So finally, we have x to the 13/4 times y to the 1/4. Okay, another example. 3 to the 1/2 times y to the negative 2 over 3 to the negative 1 times y to the negative 3. Okay, so let's just start with that base of 3. So we have in the numerator a exponent of 1/2, and in the denominator we have an exponent of negative 1. So that means we can do the subtraction of those exponents. So we have 1/2 minus the exponent on the 3 in the denominator, which is -1. Okay, which is going to end up being a +1. Now let's look at the base of y. Again, we're do the subtraction. -2 minus a -3 minus the negative is going to be a plus. And now going back to that base of 3, 1/2 plus 1, we get the exponent of 3/2. And y, we have -2 plus 3 for the exponent, so that's just going to be 1. So exponent of 1, which we don't need to include. Okay, here's another one. In parentheses, x minus x to the 1/2 times x plus x to the 1/2. So we have, okay, because both of those factors that we're multiplying together have 2 terms each, we're going to be able to use FOIL to multiply these. Okay, so we start off with the first times the first, so x times x, we get x squared. And then we take outer times outer. So we've got x is the base, and we're going to add those exponents, so 1 plus 1/2. Then we take the inner, we got minus x, adding the exponents, we have 1/2 plus 1. And then finally, the last times the last, we got -x, -x 1/2 plus 1/2. So let's go through and simplify our exponents. All right, we got x squared, that stays the same, plus 1 plus 1/2, we're going to get exponent of 3/2, minus x to the 1/2 plus 1, so that's the 3/2 again. And then minus x, 1/2 plus 1/2, we get exponent of 1, all right, which we don't actually need to write down. The middle 2 terms are going to cancel each other out, and this simplifies to x squared minus x. Okay, this next one is a little bit different. What we want to do here is factor the expression y to the -5 minus 3 y to the -3 using 5 to the -5 as the greatest common factor. Okay, so it's telling us that we know that we're going to factor out a y to the -5, and then that's going to be multiplied by something. That's what we're looking for. And multiplying those together gets us back to that expression that we're starting with. So our job is to figure out, well, when we take this greatest common factor out of this term and this term, all right, what are we going to get here and here? Okay, so if we take a 5 to the -5, or I'm sorry, a y to the -5 out of y to the -5, all right, well, that's going to be a 1, right? And then we can just test that. 1 times y to the -5 gets us back to that term. Okay, now we are going to figure out if we take a y to the -5 out of the second term, what's left over? Okay, well, there's a -3, and then it's going to be a y to some exponent, which we do not know. Okay, but if we think about going backwards, and look at the exponent, when we multiply y to the -5 times whatever this term is, we know that those exponents are going to add up to a -3. So if we take that -5 plus whatever this exponent is that we don't know, we know that that has to add up to a -3. Okay, well, if we solve for that, we see that what we're going to end up with is a 2, right? -5 plus 2 gives us a -3. So that is what that exponent needs to be. All right, if we factor out that greatest common factor of 5 to the -5. Now we can test that. Let's just go ahead and multiply. Let's distribute that factor of y to the -5 and see what we end up with. Okay, so if we take y to the -5 times 1, all right, that's going to be y to the -5. And then we take y to the -5 times -3 y squared. We get -3y to the -5 times y squared. So we get y to the -5 minus 3, adding those exponents on the y's, we get -3. And that matches what we started off with. Let's do another one like that. We have the base of p to the -3/4 minus 2p to the -7/4. We want to write that in factored form. And let's say we're given that the greatest common factor is -7/4. So we need to figure out what are the terms that go in to that other factor. Okay, let's start off by looking at this term right here. Well, if we take a p to the -7/4 out, what we're going to be left with is the -2. Okay, so that one is easy. The first term, we know that it's going to be a base of p, and then it's going to have some exponent. Figure out what that exponent is, we go backwards. Okay, when we do the opposite of factoring, which is multiplying, right? Multiplying this p to the -7/4 times this p to whatever that exponent is. We know that we are going to add the exponents. So we would have the exponent of -7/4 plus whatever that exponent needs to be, and they add up to the original exponent, okay? The -3/4. So to get what that exponent is, all right, we just take -3/4, add 7/4, and that gives us 4/4, right, which is equal to 1. So the exponent that we want is a 1, which then we don't even have to write. So the factored form, if we take out the greatest common factor of -7/4, that factor that we're left with is p minus 2. Okay, 2 more examples. Let's take a to the 1/3, b to the -4/5, c to the 3/8, all over a to the -4/3, b to the 1/5, c to the -5/8. So we want to simplify, so that means each base shows up one time, and we've got positive exponents. So let's take the base of a. We want to take the numerator exponent and then subtract the denominator exponent. So we're subtracting a -4/3. Base of b, do the same thing. Take that numerator exponent of -4/5 and subtract the 1/5. And the base of c, take 3/8 and subtract a -5/8. So doing that subtraction, we get a to the 5/3, positive 5/3. We get b to the negative 5/5, and c to the 8/8. So one more round of simplifying here. So a has a positive exponent, so that's going to stay in the numerator. B's got a negative exponent. It's negative 5/5, which is equal to 1, so that's just a b to the 1. And then c to the 8/8 is c to the 1, so, and it's positive, so that goes in the numerator. Okay, one more example for this video. Negative 2x times x to the 2/3 minus 3x to the 4/3. And we want to multiply. Okay, so distributing that negative 2x, we have a negative 2x, and adding together the exponent of 1 plus the exponent of 2/3. Okay, then negative 2x times negative 3x to the 4/3, multiplying those coefficients, we're going to get a positive 6. And then the x will have exponent of, take the exponent of 1 and add the exponent of 4/3. So we get negative 2x, all right, adding 1 and 2/3, that's like 3/3 plus 2/3, so that'll be like a 5/3. Plus 6x, adding those exponents, again, 3/3 plus 4/3, we get 7/3.